Set yourself up for an interstellar stunner. In light of the fact that, as per a gathering of researchers, Betelgeuse, the entrancing red supergiant embellishing Orion's shoulder, has proactively detonated. That's right, you heard that right. We are not kidding. Inside the following 10 years, or a couple of decades, its brilliant repercussions will enlighten the night sky. But how did researchers arrive at this claim? Should we be concerned? Might the James Webb Space Telescope catch the remnants of Betelgeuse? Today, we're plunging deep into all the latest details. Quite possibly one of the most conspicuous stars in the night sky in the northern hemisphere during winter is the red supergiant star Betelgeuse. It's among the handful of stars that shine brightly enough for us to see with the naked eye. Betelgeuse is normally the 10th most brilliant star in the night sky. But as you may already know, it has always been known to fluctuate in brightness. Part of the justification behind this is that Betelgeuse is in no way your typical star due to its enormous size. Assuming we were somehow capable of replacing Betelgeuse with our own little sun, it would stretch all the way to the asteroid belt and have a mass of a shocking multiple times that of the sun. It might come as a shock, but Betelgeuse is quite young for a star, with an age estimated to be around 8 to 10 million years. In comparison, our own sun is much older, with an expected age of around 4.6 billion years. This is because supergiant stars like this consume quickly through their atomic fuel and go supernova relatively rapidly on geological timescales. This also means they evolve quickly, and Betelgeuse may indeed have done that right before mankind's eyes. To figure out how researchers arrived at the conclusion that Betelgeuse had already detonated, it's crucial to dig into the context. The story begins around the 2nd century BC, when Chinese cosmologists made a significant observation that Betelgeuse displayed a noticeable yellow tint. Fast forward to the middle of the 2nd century AD, and the Greco-Roman space expert T.M.Y. described it as orangish or bronzed, equivalent to how it appears today. Likewise, medieval eyewitnesses in the Middle East noticed a similar tinge. The question emerges about how colors were named or seen in the past, but in this case, there is a real possibility that Betelgeuse went through a color change over a couple of hundred years. It is conceivable that Chinese astronomers observed Betelgeuse during its yellow supergiant stage, and over several centuries, it changed into the red supergiant stage. Given that people, by our nature, are night sky watchers, one has to consider how many individuals across the globe who could see the star noted the change, but left no records. After all, changes to a star like that likely came with a wide range of darkening and brightening events that weren't recorded. Imagine them gazing up at the night sky and saying, "Hey, didn't that star used to be brighter?" And that's precisely what's been occurring. Right now, Betelgeuse is a variable star, but it appears to adapt to some cyclic behavior. Beginning in December 2019, Betelgeuse's brightness unusually plunged overwhelmingly, which was apparently perceptible to the unaided eye for those used to watching the star. It was not its generally expected self until mid-2020. Over time, it recovered, and one hypothesis was that some of these cycles had harmonized, making for an especially deep plunge in brightness. Anyway, the observations made by the Hubble Space Telescope demonstrated something rather impossible to miss. It seemed that Betelgeuse had expelled a huge amount of burning material into space, forming a massive dust cloud. This dust cloud, in turn, darkened a significant portion of the star's light when viewed from our perspective. The change was very surprising. Insect squeeze, once counted among the 10 most splendid stars in the night sky, blurred to where it positioned lower than the 20th most brilliant. It was genuinely confounding to observe its obscurity, in contrast with its adjoining star, Aldebaran, which holds the 14th position with regards to brilliance. Fortunately, Scarab Juice gave indications of improvement. However, its surprising behavior did not stop. As a matter of fact, it is now showing a state considerably more unusual than simple darkening. Throughout the course of recent months, Betelgeuse has gone through a sensational increase in splendor, outperforming its ordinary radiance by a faltering half. This baffling circumstance is very disrupting for a star that is known for its changes. The darkening events could be brought about by dust or harmonizing cycles, or perhaps the star-generated colossal sunspots. Anyway, a huge increase in brilliance is something else altogether. This could be connected with the past event when Betelgeuse ejected material in 2019, which probably caused a significant disturbance in the star's plasma stream. The current behavior we notice could be considered a delayed repercussion of that release. However, what lies behind this unconventional behavior, outperforming the star's common variability? One moderate speculation that has been widely discussed is that Betelgeuse is approaching the cosmic explosion stage. While moderate estimates still suggest that the star is around 100,000 years from today's cosmic explosion event, we will give evidence to scrutinize this thought and show that it has already worked out. So, what is the proof? According to a recent scientific paper by Hideyuki and Associates of Tohoku University in Japan, Betelgeuse has already gone through a cosmic explosion, and we might be seeing the result of this inestimable exhibition in something like 10 years or a couple of decades from now. Yes, that is right. As astonishing as it sounds, the last noticed cosmic explosion in our universe was the Kepler cosmic explosion, which was as far back as the 1600s. Through an intensive assessment of Betelgeuse's inconsistency patterns, the analysts have found 4 particular occasional changes happening at time spans of 2,200, 420, 230, and 85 days. While the beginning of the longest period remains obscure, it is guessed to be the major period, with the more limited spans possibly filling in as reminders. The scientists propose a model suggesting that scarab juice is in a late phase of carbon burning, implying that it could be very close to a tremendous blast, situating it as a conspicuous contender for the next expected cosmic explosion event within our Milky Way galaxy. Regarding unwinding the mystery surrounding scarab juice, there's a bit of a riddle. You see, there are some conflicting perceptions about the discharge of materials and the star's subsequent recovery. The overall consensus leans towards a mass discharge event, something not totally incredible for different types of stars, albeit on a more modest scale compared to our own sun. But here's the twist. Supernovae are a real thing too. We actually saw one in a satellite galaxy of the Milky Way back in 1987. So, while it's conceivable that our estimates for Betelgeuse's explosion timing could be off, don't go planning a getaway around it right now. The interesting part is that Betelgeuse is currently too precarious to notice. It has slipped behind the sun and will not be apparent in the future until at least August. Thus, we're left in the dark about what this baffling star is up to right now. What we do know, anyway, is that it's kicking its common patterns by lighting up. Now here's something fascinating. Betelgeuse's tremendous size and relatively close proximity, roughly 650 light-years away, permit us to determine a plate, as a matter of fact, while noticing it. Most stars are just too far away, showing up as simple points of light. However, with Betelgeuse, we have an interesting opportunity to capture direct variations in its light output through photography. So, we not only have a star that could potentially go supernova, but also plenty of information to gather, including pictures, even if they might be a bit foggy. We should envision the situation where Betelgeuse actually has, for sure, gone supernova. How might it look? Priority straight. It will be a genuine display. But don't worry. It's completely all right for us here on Earth. You see, Betelgeuse is quite far away, so it will not actually hurt our planet when it goes supernova. However, it will not be the most brilliant object overhead. The moon will still surpass it by a wide margin, and we should not disregard the sun. Anyway, it would create its own shaded areas at night and stay visible during the daytime for about a year. Now, here's the interesting part. The supernova would be apparent at night for quite some time, progressively disappearing. There may be a brief period where it regains some of its previous splendor, but ultimately it will continue to blur until the recognizable shoulder star in the constellation Orion vanishes completely. While this supernova won't pose any threat to us, it could cause some confusion, without a doubt. Some creatures depend on twilight for navigation, and with an extra brilliant light overhead creating shaded areas, it could cause them to lose their game a little. But that's not all. Space science itself would face some challenges. Noticing the night sky from Earth during times when the moon is shining brightly can be a bit tricky. An extremely brilliant supernova would just complicate matters further. However, many telescopes would probably be more keen on capturing the supernova's brilliance than anything else, even if it means changing their observations. there would be a few admonition signs previously. The noticeable blast-like identifying neutrinos and gravitational waves from the star. However, here's the unavoidable issue. If Betelgeuse has already gone supernova, might we catch the remainder? For that, we need to wait for the James Webb Space Telescope to distinguish the cosmic explosion's remnants. So, how long might it take for Betelgeuse to go supernova? We're not totally certain yet. It could occur as soon as next week, next year, or in 100,000 years. In astronomical terms, that is fundamentally equivalent to right now. After all, forgetting that the light we see from this star is, in fact, extremely old, and if it exploded 600 years ago, we wouldn't even know it. What do you think? Might Betelgeuse have already gone supernova? Or is it just showing some strange variability? Let us know in the comments. The James Webb Space Telescope is, obviously, the ideal tool for making these observations. We shouldn't wait too long before it tackles the mystery once and for all. The journey to comprehend Betelgeuse's behavior and its implications for stellar evolution involves a multi-layered approach, combining observational cosmology, theoretical modeling, and historical context. This star, famous for its variability and massive size, provides a unique opportunity for astronomers to study the life cycle of very massive stars and the peculiarities leading to supernovae. It's essential, right off the bat, to handle the meaning of supernovae in the broader context of stellar evolution. A supernova isn't just a dramatic event. It's a critical process in the life cycle of stars. These blasts play a crucial role in dispersing heavy elements throughout the universe. These elements, forged in the cores of massive stars, become part of the interstellar medium and contribute to the formation of new stars and planetary systems. Consequently, the investigation of Betelgeuse and similar stars helps cosmologists understand the chemical evolution of the universe and the mechanisms driving stellar evolution. Betelgeuse's looming or recent supernova event would mark a vital moment in this stellar life cycle. Researchers are especially interested in the mechanisms that govern the transition from a massive star's last stages to its explosion. Current models suggest that as truly massive stars, like Betelgeuse, approach the end of their lives, they undergo a series of complex processes, including core collapse and the ejection of outer layers. These stages are characterized by significant mass loss, which can affect the star's brightness and variability. By observing Betelgeuse's changes, scientists can gain insights into these processes and refine their models of stellar evolution. Moreover, the historical records of Betelgeuse's brightness variations and its recorded brightness changes offer valuable clues about its past states. However, ancient astronomers' observations, limited by the technology of their time, have provided an estimate for comparing current data. The shift from a yellow hue to a reddish-orange tone over centuries could reflect the star's internal changes and its approach to a supernova. This historical perspective enhances our understanding of how massive stars evolve and how their life cycles impact their surrounding environments. The potential for Betelgeuse to become a supernova also intersects with our understanding of cosmic events on a larger scale. The study of supernovae helps astronomers investigate the circumstances leading to various types of explosions. For example, Type Ia supernovae are often the result of nuclear explosions in binary star systems, while Type II supernovae, like those likely from Betelgeuse, arise from the core collapse of massive stars. Understanding the differences between these events can help researchers decipher the history of our universe and the frequency of such occurrences. Observational challenges, like Betelgeuse's current position behind the Sun, highlight the complexities involved in studying such dynamic celestial objects. Despite these challenges, astronomers employ various techniques to monitor stars that are temporarily obscured. For instance, they use space-based observatories and advanced telescopes to track the star's light curves and analyze its spectral data. These techniques provide essential information about the star's composition, temperature, and potential for a supernova. Additionally, theoretical approaches, including the use of modeling, play a crucial role in predicting and understanding supernova events. Researchers develop simulations that integrate current observations, historical data, and theoretical physics to estimate how a star like Betelgeuse could behave. These models aid in predicting the timing and characteristics of the supernova, offering insights into what spectators might expect and how the explosion will affect the surrounding space. The implications of a supernova from Betelgeuse extend beyond the realm of astronomy. For example, a supernova of this size would contribute to our understanding of cosmic radiation and its effects on Earth. Although Betelgeuse's distance ensures that it poses no threat to our planet, the study of supernovae contributes to our knowledge of cosmic rays and their relationship with Earth's atmosphere. This information is vital for understanding space, weather, and its potential impacts on satellite operations and communication systems. Finally, the potential discovery of Betelgeuse's supernova remains a source of energy and interest within the scientific community. The event would not only enhance our understanding of stellar life cycles, but also captivate the public's imagination. The dramatic visual effect of such an explosion, visible for months or even years, would undoubtedly inspire a new generation of cosmologists and space enthusiasts. Public interest in cosmic events often stimulates educational outreach and promotes scientific literacy, emphasizing the importance of continued investment in space exploration and research. In conclusion, the potential supernova of Betelgeuse represents a significant milestone in our understanding of stellar evolution and cosmic events. The ongoing observations and theoretical work surrounding this star contribute to a broader comprehension of the universe's workings. As we anticipate further data from the James Webb Space Telescope and other observatories, the study of Betelgeuse continues to provide valuable insights into the dynamic processes governing massive stars and their ultimate fate. Whether Betelgeuse has already exploded or is approaching that dramatic event, its story highlights the ever-evolving nature of our exploration of the universe and the ongoing quest to uncover its mysteries.